Hi, I'm Philip, and in this video I will show you the Revopoint POP 4. So Revopoint was kind enough to provide me the scanner for testing, but all things I say and all the opinions about the scanner I have are my own and my own experiences. So the scanner arrived with how is it called, DHL Express. Maybe a bit about the background, how you can get the scanner. So this is the first to get out of the way. So I have some printouts of from the Kickstarter page. So currently the scanner is on Kickstarter. I think there are 2 weeks left on a Kickstarter. I have the pricing noted here. So there is the normal set of the scanner. So let's see if you have a list of what's in the package. So there's the normal scanner or the normal package. It's basically just a scanner with the cabling. And currently it goes for $643, I think. And there's the special edition. This has the wireless kit. So it's basically a power bank for the scanner and a connection cable, or a short connection cable, and outdoor filters. And this one goes for $745. And in the Kickstarter special pack, there's also a bit nicer carry case. This is the special edition. I already had a quick peek in to ensure that nothing was damaged, because it seems like DHL already dropped my packaging. So I guess for the normal units, they will be shipped from local distribution centers and not across the globe. To the pricing I just mentioned, there also is a $50 shipping fee. But what's good, the taxes are already included. I checked the Kickstarter page. Initially, the pricing even started at lower. So for the normal edition, it was under $600, and for the Kickstarter special edition, under $700. And this is a laser scanner, so that's pretty great. Converted to euros, so I'm Germany, so euros are the more interesting one for me. Including shipping at the current price, it's roughly €600, and the special edition is roughly €700. Maybe a bit about Kickstarter. So with Kickstarter, you have to keep in mind there is no guarantee that it will be delivered, but I believe it will be delivered because I already backed the Revopoint MetroX 2 years ago, I think it was. And it was delivered in time, so just before New Year's Eve it arrived, at roughly between Christmas and New Year's Eve. So this was very smooth. And I also backed the Revopoint Track It, so both with my own money, and it also arrived, and they delivered what was promised. So I'm not having too much doubts or any doubts at all that they will deliver. I think the delivery date for the POP 4 is already at somewhere in June, I think it was. So you should get it quite in near future. Otherwise, if you want to wait, you can of course buy it on the normal online store, the distributors, when it's released, and then it will go for a bit over $900. So the normal price for the POP 4 edition is $919. So it's still quite a compelling price for everything that's included. But what the scanner can do, we will have a bit of a closer look when we unbox it. I also have the spec sheet here of the Kickstarter page, so keep in mind. The box it arrives in, it's I would say the typical Revopoint white box. And what we are directly having in this package is the aforementioned carrying case. That's part of the special edition. So this is I don't know how I would call the surface. It's a bit of a leathery texture, so it's quite a compact unit. So when I initially saw it on YouTube, Kickstarter, I had the impression it would be a bit larger, but this is quite a handy size. So it will also fit in my smaller backpack. So that's always quite important for me, that the cases are not too bulky. Also compared to the MetroX case, I just have it on a shelf over me, or MetroY Pro case. This one is roughly, for comparison, 1.5 times the size. I can just pull it out of the storage compartment here. And so let's zoom a bit out like this. How can I switch the cameras? Okay, I sadly cannot switch to the widescreen right now, but this should give you quite a good impression that the size difference is quite large and the POP 4 is very compact. So let's put this back up and now let's have a look in the box what's in there. So let's maybe start at the top compartment, because that's where the calibration board is. So it's always like this. What you're also having is a pack of 6mm markers. I would think that it's roughly 500 of them. These are plenty, but I still would recommend you, if you have a 3D printer or if you use the spares, just print yourself some marker geometries. So basically, these are like the decadons or hexagonal shapes. I 3D printed with markers on them, and then you can just place them around the part, or maybe get a small turntable or place markers on the included turntable, because you still don't, you just don't want to waste them, because why would you? Then you also have a quick start guide and some software tips, I guess, including download links, where to get software, and a small warranty card. The quick start guide is actually quite thick one, a quite thick unit. But now let's put this back in the case, and here at the top we have the calibration board. So let's have a look. It's similar to all other calibration boards of the Revopoint scanners. Of course, it's like fitted to the case, so it's a bit smaller, but it's made from glass. I guess it's some sort of silicate glass that is quite accurate across the temperature range. On the back side, we have like a sticker with the calibration code. So basically, what they do is they manufacture this board in their factory. And then there's like always a bit of an error when printing these boards. But what you can do is you then measure with like a higher standard the board and the dot spacing, and then you save it in a QR code. And then the scanner knows exactly what's or how the point spacing should be on the board, and this data is then used for calibration. What's also important, if you handle these boards, just grip them on the side, because you don't want to get smudges on the front face, or even worse, like scrape some of these marker dots and these coded targets, because this could decrease your calibration results. But best is to just store it in the included bag most of the time, unless you are calibrating it. And this bag is also a good good ground for calibration. So when you calibrate it, take it out of the bag and place it on the bag so it doesn't get scratched. Let's close the top compartment now, and we can have a look at it later when we do the first calibration. And now to the bottom, here's like the main thing playing. So in the background I have a few of my like personal notes spaced out, and so I try to include as much technical information as I think is needed. First thing we have is a small turntable. It isn't lit up. The good thing is now they finally use USB-C. So the initial turntables that were like with the older POP series, they had micro USB-C, or how is it called? Micro USB Type B, USB Type B, I guess it is, but it's Type C now. And I can also just start. It just says that you also have like a small knob for the speed adjustment. So theoretically, you can print a bigger knob if you want. Maybe I will actually do this. And what you also can do, or could do, is place or glue markers on top of this turntable. If you have a big printer, what you also can do is, maybe I will actually design one for this turntable, is to just use this turntable like in the without markers for the normal scanning, and then have a bit bigger top surface where then with markers that you also can store here in your compartment. So maybe here on the top there's still a bit space left. I will just design a round plate that can be snapped on to the turntable and be used with markers. So this may be helpful. So I'm always like tinkering a bit with the scanners and adding some personal touches, I would say. So don't be surprised. All right, then this one can be tested later. But I also have a bit bigger turntable here on the side. Then we have a small ball-headed tripod. So you can see it's like in the core, you have like the tripod and the ball head on the top. And this is one of the ball heads you can just like lock with a screw. So yeah, I would say this is quite handy in combination with the tripod. You also can extend the legs. And here on the back side, you have a push button to release them again. So then I would say this is like the included parts. It's the optimal setup for something like miniature scanning or scanning smaller parts. If you want to scan bigger parts, most of the time you're either not fitting them on a turntable, or you're anyway using like something like marker cards or the marker geometries I just shown you. But now let's stash these also back in the package. I will have a look at the scanner last, so keep waiting. Then we have the battery. This is actually, I have this data sheet here for the scanner. It only uses 5 volts at 2 amps per data sheet. This power bank actually can output up to 12 volts at 1.5 amps. But the scanner only needs 5 volts, so this is actually quite nice, I think, because with other scanners like the Revopoint MetroY Pro that use 12 volts, because they have higher power requirements, these like small battery banks are a bit hard to find that can do 12 volt static output without power delivery protocol. But with the regular 5 volt, this is like the normal USB spec it can always do, so it shouldn't be any problem to use different power banks. But maybe if you're like a bit uncertain if it will work, check with them first or ask the support, because I don't want your scanners to be damaged. Then here on top we have like wiring. We have a normal connection cable. This is the one when doing like wired scanning, not wireless. I will come about what the scanner can do in a few minutes. Maybe you already seen it on Kickstarter. So this is a USB-3 cable. On one side it's locking, so it has like a screw terminal. On the other side it also has 2 USB-C. I just had to grab an additional cable, I'm sorry. So on the other side we have USB-C. What I personally quite like to use with these USB-C to USB-C cables is a small adapter cable. So this is the wrong one. The correct one is currently is my office, not here in the workshop. But it's basically the same principle. So you can use this adapter cable, this very small extension like this, and then you have a bit of a strain relief. So if I should bump over the cable or maybe snatch it somewhere, it just disconnects from here, and there's no damage or no potential risk of damaging the USB-C port or the cable itself. So it can be quite handy. Then we have a very short adapter cable. This is the aforementioned one for the special edition. And this goes basically between the power bank and the scanner itself. So it's just, I would say 20 to 30 centimeters long USB-C to USB-C cable. The third cable that's included is for the turntable. So this is also just a regular USB-C to USB-A cable. I have a power supply right in the back, so I can try out the turntable. So let's plug it in. Now let's move this to the side and plug in the turntable, and it should already start rotating like you're seeing here. And I have to turn off the 3D printer. It's starting to vent its chamber. So as you can see, the turntable is rotating. I hope you're seeing it. Or you can see it like here in the light. And with the knob on the side, I can adjust the rotation speed, because for very small parts, if you want to get high detail scans, it may be beneficial to have the turntable rotating slower. And you also have like just a reverse button, and the center position is off. So you can adjust the rotation speed and the side it rotates. Now let's put this cable also away and get to the last smaller item in the package, and these are the auto filters. So you can see them here. They are part of the special edition package, and if I open it now, these are basically, I hope you can see it like this, sunshades for your 3D printer, for your 3D scanner. You can snap them onto the cameras, and these allow you to scan outside, even laser scanning mode, up to, I think it's 100,000 lux. So the default, the default, I would say, spec for the auto scanning is with the multi laser lines, it's under 50,000 lux, and with the VSCEL, it's under 100,000 lux. With these sunshades, you can also use the laser mode up to 100,000 lux. So if you want to scan outside parts, these may be a sensible accessory to get. Let's put the cables back in and have a look at the scanner itself. So it's quite a handy unit. When first seeing like the pictures on Kickstarter, I thought it would be bigger, but this is even quite, I would say, a compact size. It's a bit of like the distance of the small cameras on the MetroY series, I think. And it's quite packed with cameras and sensors. So it's maybe go a bit through the different scanning modes, what you can do. So you have here the big emitter in the center. It's the full field emitter. So it's a bit like, from my understanding, like in the full field mode of the MetroY series, Y Pro series, but with infrared light. Then here on the here on the side, you have the infrared VSCEL emitter. So VSCEL is, I think it's called for vertical. Basically, it's a laser diode that emits infrared dot points or dot projection. It's a bit like Face ID on an iPhone, but in beefed up. And here in the center, we have the three laser emitters. So here you can see the three holes, I think, in the reflection. So two of them are for the cross laser lines. There we have 30 lines. So basically 2 times 50 lines. And we have one single line for deep hole scanning. So I actually noted myself, so with other scanners that have like parallel line scanning, most of the time I'm either using the crossed lines or the single line mode. So I think it's okay they left out the parallel lines, because it in this size it would be quite hard to fit in more emitters in the center, I would say. And then there is a fifth scanning mode. It's called Hyprid HD scanning. So this is a combination of the full field and the VSCEL. I still have to do some more testing of this mode, or actually some testing of the scanner, so then I can have a bit more funded comments about it. But the good thing, it's a laser class 1, so you can it's eye safe. If you feel uncertain or unsure about it, maybe still use glasses with the blue laser lines, but I think it would be okay. Then for the cameras, so basically with this one you have 2 cameras for the depth scanning and 1 RGB camera. Here you can also see what's quite interesting. You can see the 2 fill lights for the, so aside of the RGB camera, you can see 2 fill lights for the color capture, because it can also do color capture and it can also do Gaussian splatting. This is one of the things I'm quite interested about. Maybe a bit of a background. So I normally mainly do like reverse engineering and a construction based on 3D scans. But I'm also dipping my toes in LiDAR scanning in the recent months. And one of the paths that you're certainly, or that you're, the foxholes you go in when LiDAR scanning is Gaussian splatting. And I've quite came to like them for like VR representations of scans for customers or customer sites. And one of the gaps I had was like Gaussian splatting of smaller parts that I want to place in my bigger locations. So this could be quite interesting. So I hope I will test the software, how the Gaussian splatting workflow is, because if I can then just like quickly capture smaller parts, this will be quite useful to like compose bigger scenes with Gaussian splats of LiDARs. Then what you also have is a bit of some extra fill lights. So I guess from my experience, I would say, so you can see the lights around the depth cameras a bit, or the LED as a bit different colored. So I guess 2 of them will be blue colored and 2 of them will be infrared for each camera. What you're also having is like a regular, I would say, 1/4" screw to adjust to attach first like the battery handle like this. And I initially was a bit skeptical about the ergonomics of this package, but if I now try it out and connect it like this, this is actually very good. I can easily reach the buttons, so that's not bad. So I was skeptical because, like, looking at it from the side, it's a bit like not too, I would say, ergonomic looking. The only thing that I'm maybe constructing for this one is a smartphone mount, because that's also one of the features I'm very interested in. The POP 4, of course, it works with your PC. It even now luckily supports macOS and the Apple Silicon chips. So I'm having like the minimum requirements right in front of me. So for macOS, it's at least for minimum, it's a M1 Pro chip with over 16 or at least 16 gigabytes of RAM. For Windows, it's like any, I would say, decent i7 with I guess also the newer i5s with also at least 15 gigabytes of RAM and an NVIDIA GPU. The recommended specs are of course a bit higher, but I would say it will run on most of the devices. But what's good, it can also do scanning with the smartphone. What you can have to keep in mind, I would say you need basically any iPhone or a very good Android phone. So that's basically the spec. So yeah, I'm getting more interested in Apple products in recent time, because I saw I think it was an iPhone 16e churning. I think it was like 50 FPS in laser line mode, and my then like high-end Android smartphone was doing half of it with an IR scanner. So yeah, they are quite good optimized. But sadly, for context, what I can do today is like do a first test scan and calibration in the Windows application I have on my notebook. The smartphone app hopefully will be like in a beta test version next week. Then I can give you a bit more concrete examples, because for the smartphone version, what you can't do currently is the multi-line laser scanning in the smartphone app. But what I can do is the IR, so the VSCEL and the full field scanning, and I think also the single line mode, as I'm understanding it. So this is quite nice because I then can just like outdoors, can scan outdoors. And what I guess I will construct is like some sort of smartphone holder that places the smartphone here on top of the scanner, so I can have like a immediate preview. I initially was thinking about fitting the smartphone between the handle and the scanner, but I think it will work quite well on the top, because as you can see, I can also very easily reach the buttons. So as a right-hander, even better, but also as a left-hander, it works quite good. So this, yeah, that's quite good news for me. But now let's plug it out and try fitting the lens protectors. So I haven't tried it yet. So this is also a first for me. So let's maybe move this package to the side and zoom a bit in, like this. So, and the video is already getting long, but I hope you can understand. And I don't want to make like short 15-minute videos without talking about all the details. That's simply not my style, I would say. I tried it out a few times. But in cutting or in editing the videos, I just noticed I don't want to cut out the information. I also don't want to condense it too much. I will put like links to the relevant parts of the video in the YouTube timelines. You can skip around, but for now it will be a long video. And I think they are magnetic fits. So this is quite good. And now for getting them off, they have a small groove on the side. So I will certainly test it outside, because what you also can do, I don't know if I already mentioned it, you can connect it wired to a PC, or you can do it wireless or Wi-Fi, and it will also use this connection to the smartphone. About scanning speed maybe a bit. So for context, how it evolved. So the MetroX started with 60 FPS scanning speed, like 2 years ago. And it was like, it was also priced roughly around 800 to 1,000 euros, I think. This one is now started at under $600, or dollars I think it is, or then converted to euros, roughly 500 euros. In the cheapest tier when the Kickstarter started, and this can do 105 FPS in laser scanning mode. So this is quite fast. Well, it got quite fast in the recent years over time. The IR mode can do, I have to look at my spec sheet, I'm sorry, where it is standing. Yeah, here I have it. So the full field structured light can do 15 to 20 FPS. The VSCEL structured light 20 to 30 FPS. I would say this is like the industry standard to some point. For context, so the 105 FPS maximum speed in laser scan mode, this requires an NVIDIA GPU. With CPU rendering, you still hit like 40 to 60 FPS. So this is actually quite good that it at least supports CPU rendering or processing. Other scanners, they simply have like a hard requirement for an NVIDIA GPU. And with the recent Revo Scan updates, the CPU rendering actually quite improved. So I still have a video in my editing to-do list about the CPU rendering performance increase. Basically, it was from initially like only a emergency solution at like 20 to 30 FPS on my, I would say it's a thin and light notebook of from Lenovo, to 40 to, I think it hit roughly 60 FPS, and it worked quite good. So this is very good if you have like some small sort of bit slower or bit lower class, lower spec notebooks, and still want to start with 3D scanning. Maybe about the scanning area you can do. The laser scan area is basically similar to the MetroY series. The VSCEL mode is roughly, or the infrared mode is 1/2 by 1/2 meter scanning area at 800 millimeters distance. The multi-line laser mode is kept at 400 millimeter scan distance. The full field mode, so this one with this emitter, is kept at 500 millimeters, and the VSCEL mode is at 800 millimeters. So for scanning, I would say VSCEL for larger parts or large organic parts, laser modes for like your reverse engineering parts or reverse engineering tasks, and the hybrid mode and full field mode, I still have to test it. I would say if the hybrid or full field mode is similar to like the blue light hybrid mode on my MetroY Pro, I'd feel like be a very good fit for very, very tiny parts like a miniature scanning, but we will still see. What you can also do is, because I talked about mounting a smartphone here on the top of the scanner, when you're doing PC scanning wirelessly, so the scanner is connected or Wi-Fi to the PC, you can also, there is the Revo Mirror app, it is called. So this basically is an integrated screen mirroring function in Revo Scan, so you don't need to use like remote desktop to get a view of the PC screen while walking around. And this will just display you all the most important facts while scanning. And this, I really want to do like a smartphone mount here on the top. I maybe have to think about how I will realize it, but I will do a smartphone mount on the top. I just decided. But now I guess we talked about all the relevant, I would say, specs and what you can do. And now let's start up the scanner and start with calibrating and go into Revo Scan 6. So the the POP 4 by default uses Revo Scan 6. I already did a video about it, and from I would say my personal opinion about Revo Scan 6 is very good. So this is basically a big improvement to the workflow, and it got more, I would say, professional. And the POP 4 is connected, as you can see here in the bottom. So I now can start with the calibration process. And this is, I guess it will be like the calibration process with all other scanners. So it shouldn't be, too spectacular, not too surprising. But now let's let it load. Keep in mind the software is still in a previous state. So this is not the final mode, but I'm already seeing the laser lines being emitted. And yeah, as I guessed, I hope you can see it here. We have the blue lines, we have the laser lines, and the first thing we need is the camera or the QR code scanning. I already know the prompt, so basically how to do scanning. It's with like with all other scanners, the good thing is the software really guides you through the whole calibration process. And you just start scanning like this. And from my first impression, it feels like this. It's center it. Now you're centered. And now I can start calibration. And you basically do multiple different distances. So let's like this. Okay, accuracy check failed. So because this is basically the first time I'm doing the calibration, so I can just like center it like this, a bit closer. Okay, I need to do it left-handed, otherwise. Okay, I already get it. So this is much improved. Now next distance, and due to the fact that we're using the IR mode also, it goes up to 45 centimeters while calibrating. But now let's skip forward in the calibration process. So like this. And like this. Okay, now we need to tilt it to the side, and okay, now I get it. You're supposed to hold it like these angles, and then also like the display movement is okay, this is much easier now. So you just need to hold it in like the picture shows. Then the calibration instantly gets easier because the movement on the screen are like the movements in real life. So yeah, look at the tutorials. What you also can hopefully see is that the signal line is quite bright and the blue lines are very sharp. I hope you can see them a bit in the camera view. Now 2 calibration steps left, one angle to the first side, and I hope, okay. So don't make the same mistake as me, just hold the scanner as the software tells you to hold it, and then the calibration will be quite a lot easier to do. Like this. I hope you can see it's a bit faster now. And the last one. So. And now we are calibrated, or the calibration results are loading. And as I said, I'm finished with calibration, so I'm immediately putting it back into this I would say, how's it called? Not silk, it's like velour bag, I would call it, to keep it protected and don't smudge it. I will also already prepare my wireless kit, because I will of course use the scanner wireless, because as soon as you are, like I would say, accustomed to some wireless scanning, it's quite hard to go back. So now we are back, and I will now move my notebook a bit to the side, or maybe here a bit on the top, and I will show you my first scanning subject, and this is my trusty anatomical skull. But now let's move it a bit out of the way. Now this is much better, so you can see what I'm doing. I will just have in this video a quick look at the different scan modes. So a proper like testing with all different modes and how to use the software will come, but I guess we are already at half an hour, and I don't know how much longer you will want to listen to me, this video. The scanner is now again connected, and the first thing I will test, or maybe this is one of the things I'm very interested in, the speed difference between like wired scanning and wireless scanning. So I just create a new scan. And the good thing is, what I think it's quite good with the Revo Scan software is that the scanning workflow is a bit more intuitive. So it first starts you how you want to track, because this is oftentimes the main limitation. So for example, for the skull, I have markers here on the table, and I can even put a bit more markers on the table itself. So these are like the marker geometries I mentioned before. What you also can do is, if you're like not using or not having a turntable, you can just glue these markers on some metal business cards. So I have basically aluminium or black aluminium business cards I glue markers on. I think you can also directly buy them from ASAP. And due to this reason, we can use marker tracking. And then it shows me the support modes, the scan modes that are supported by markers. If I would do feature tracking, which would also work on the skull, or mainly on the front side of the skull, because we have a lot of like, I would say surface geometry. This is for feature tracking, surface geometry is needed. What's the other option is color scanning or color tracking that uses the color. Maybe this skull will be a bit hard, but what it also will do, even in color mode, your markers that are on the skull, they are still recognized because they have very sharp or very significant color differences. So even in color tracking mode, markers can be a big help. And even you can have maybe a special look. On Amazon, you can find like markers that aren't highly refractive. They are basically white dots or white stickers with a black border around them. And these are like very good for color tracking, because especially outside, they aren't reflecting as much, because for laser scanning you have like these reflective targets. I don't know, I don't think you're currently seeing it, but they are a bit like the reflectors you have, for example, on your bicycle or on road signs. But for this one, we will do the marker tracking. Just a short look what scan modes are supported. So in the laser scanning mode, there is the cross lines and single lines. So these are two scan modes as a Revopoint system. For me, it's like the laser scanning mode, and I can, while scanning, switch between the cross and single lines. For feature tracking, we have like the full field, the VSCEL, and the hybrid mode. Then for the marker tracking, we basically have the full field and the laser mode. Global markers are a bit different. So with the normal marker tracking, while scanning, the scanner discovers the markers and uses them to orientate itself. With global markers, you start only capturing the markers and not the geometry itself. Then basically the marker layout is optimized by the software to get more accuracy. So the accuracy spec of the volumetric accuracy spec, this is the one I'm most interested in, is 0.03 millimeters plus 0.05 millimeters per meter scanned with the POP. So this is like, I would say, any high-end scanner or very good scanner in recent time. This spec is for the laser mode. So the laser mode will be the most accurate one. As I previously said, laser mode is the one mode I use for reverse engineering. The other modes are very good for like organic parts, or if you have miniatures where the top accuracy isn't as important. I will of course also test the accuracy of this one, first with my micrometer test, and I'm currently also like trying to get a proper ball bar or something like this, or ball gauge, to do a bit more sophisticated accuracy scanning. Because I know there are like the mythology of the micrometer isn't the best, but it's the tool I have. But now let's start with the laser scanning and just call it skull laser. And I can start. So this is quite, I would say, intuitive workflow. And now if when the software is started, I can just enable the auto exposure, and the rest is figured out by the software. So like this. And now I can start scanning. So this, the tracking is very good. Damn, this is impressive. This is actually impressive. So currently we are at 0.3 millimeters of resolution, and this is actually, so even if I go here to the top, so with my, I would say, no, maybe what we can do is we can improve the scan distance a bit to the maximum value. Then the top shouldn't be much of a problem to scan. So I'm thinking about like my initial, I would say, touching points with laser scanners. I started with the Quality Raptor, so the initial one that had like 7 laser lines, and cost, I think it was 1,500 euros without Wi-Fi. Then I got the MetroY, which had like the 14 modes, laser lines, and initially, the Metro X with Kickstarter. And initially, like GPU rendering wasn't even there. It got added with a software update. But this, for the price point of like, of course, if you buy it regularly, it costs 900 euros, which is still a very, for this, like, only for the laser scanning I'm seeing here, it's a very fair price. But with the Kickstarter special for under, I think it's under 500 euros initially, or 500, yeah, euros initially, or 600 now with the current tiers. This is very good. This is shockingly good. So, damn. I hope you can, yeah, I would say, hear my experience. So, what I can now also do is, let's have a look. Well, let's maybe test it. So, new scan, current group. Oh, so, yeah, okay. It's still mainly accustomed to the Revo Scan 5 of my Trackit and my MetroY Pro. But what we now also can try out is the single line mode. So this was the cross lines, and now I can go back to automatic exposure. Ah, we have the high accuracy. This wasn't even the high speed mode. Okay, this was the high accuracy mode. Yeah, this is quite impressive. But now let's look at the single line mode. And as you can see, it just, yeah, like, let's start scanning. This one now hits roughly 110 FPS. Due to only being one line, it's of course a bit slower. But I think with the M button, let's see, M button plus minus to, so you can control the software with the buttons on the scanner. So I actually forgot the buttons, I'm sorry. What you're having is you have a start stop button, you have an M button. This M button also opens like a quick menu where you can use plus minus to select the different options. Then you press the play button again to select the mode you want to, or the option you have. And with plus minus you can then switch. So now M button, I want to go to the switch now. I want to switch scan mode. Okay, and now I can use plus minus to switch between the cross lines and the single line. But this is like really impressive. Now, maybe one thing I still want to try. Now, I promised you I won't be going too much in the software, but some things I must try right now. I'm sorry. So this is like the high-speed mode. Now let's have a look. We are still at 0.3 millimeters, and also 0.3 millimeters resolution, target resolution, and this is, yeah, quite fast. Damn, this is really quite fast. Okay, that's impressive. But now let's delete this scan, and the one I will be looking at as like a first example is the, so is this one, this the skull I just captured. And as you can see, the software is just, yeah, guiding you through it. First thing we will do is the fusion process, and as you can see, it is quite fast by now. So I know with my first laser scan experiences, the fusion or the processing took quite long. I think it was like, I don't know, 10 minutes for such a scan could be realistic. But now this is quite quick. Under the, yeah, that the progress bar isn't lying, but it looks like it will be finished. So here again, I just got a call, I'm sorry. But now as you can see, we have here the fused model. And now I can directly go to meshing. So this is like the fast setting. So this isn't like the high accuracy or high quality meshing, but even the point cloud preview looked quite impressive for the first test. But now if we have a look, this looks quite good. So the surface is a bit rough. What I guess is the reason for this small roughness here on the side. So I'm scanning on this turntable and I had the automatic exposure enabled, and this will cause the scanner to try to find the proper exposure to both scan the turntable, which is quite dark and therefore needs very high brightness, and the head itself, which is very light color. So if then the exposure and laser brightness is too high, the head itself will be a bit rough. But this is like the quirks of 3D scanning. You just have to know. Well, you have to experience, I would say. Now let's try out the other mode I now want to. First, let's try out the full field mode and see how this is working. And I will basically just set all the values to the automatic one, or to the automatic mode. So like this, auto, everything is in auto. So, and we are hitting, I guess my PC is really lacking, or my notebook is lacking a bit of power for this mode. But as you can see, this is even faster at capturing data. So per spec, the laser mode should do 2 million points per second, or scan points, and the full field mode up to 5 million. And I think what I quite like is that the full field mode is IR. So this also allows me to use it on people. So with like traditional VSCEL, I often have the problem that face scans are a bit difficult because with the blue light, people don't have their eyes open, or cannot leave their eyes open. And as you can see here on the side of the turntable, I also captured my arms a bit, so that's quite cool. So now we have the full field, and now I also want to try out the VSCEL mode. For this one, I will just use the feature tracking. And let's see, it's loading. And I really hope I can test the smartphone connection next week. So this is loading up. And we even, as you can see, like in the IR mode, you need to be a bit further away. And due to this big scan distance, I will now also not rotate the turntable, because as you can see, I'm capturing the wall behind the scanner. And if I would now rotate the turntable, this would basically lead to tracking loss, because it still tracks the wall, but the position is different. So this was also quite fast. And after I edited all of the scans, I will also show you a short comparison of the different scans, so you can get a quick feel. But I don't want to show, I don't want to make you watch me processing all of them. And the last one will be the hybrid mode I will test, and then I still want to see the speed of the laser mode and wireless. So I really hope it will also hit 100 FPS, but we will see. So now let's set it to auto, everything in default settings, and just give it. So this hybrid mode is faster than the full field mode, or the full field mode itself. And I guess I will need to have to look at the different settings, or different parameters, to get a better feel about the proper modes to use these for, proper scan scenarios to use this for. But this will be enough for the first one. And one thing I maybe still want to try out with one of the very, I would say, dominantly advertised features of the POP 4, or better said, of the Revo Scan 6 software, is AI segmentation. So this is basically meant to allow you to like dynamically select what you want to scan. So with the previous scan, I was showing you that, so in the IR mode, it also is capturing the backdrop, and I don't want it because then rotating the head itself will be a bit hard. For this is like the IR mode, or object segmentation it is called. So what you have, like you have different options here with the removal. So the default mode is a base removal. This just detects a base plane, and while scanning it will then remove the table. But what I'm more interested is the object segmentation. And as you can see, it already initially detected here the head. But I can, by basically here in the camera view, by so like this, by left clicking the parts I want to keep, it adds to the segmentation. And by right clicking, I exclude it from the segmentation. And what's best is, before starting to scan, just go around the head or the part you want to scan and ensure all of it is included. Of course, the segmentation will work best with like evenly colored parts. But now I should just, will it detect my hands? No, it will not detect my hands. So I would say this is like the default example. And as you can see, it doesn't pick up any of the wall. It doesn't pick up the turntable. And if I hold my hand in front of the scanner, you can see the shadow of the hand. So this is also actually quite good. So I thought, honestly, I thought it was a bit gimmicky in the start. But now when trying it, I can certainly see my, I would say the use cases for it plopping up in my head. But yeah, so this works very good. Damn. So, damn. And as you can see, this will also make the processing faster because I didn't capture any chunk data that I won't need. But now save this one. And now I will first unplug the scanner and try out the wireless speed of the laser mode, because this is one of the settings I'm very interested in, or one of the performance markers I'm very interested in, because I haven't seen in the spec sheet there is no explicit mention of the speed in wireless mode, but we will find out shortly. And for connecting, I should just need to like connect the cable between the POP and the battery, and then the scanner will start up its own Wi-Fi network. And as you can see here, POP 4, I can connect to the network, and then I should see it pop up or being connected in Revo Scan. So let's try out the speed of the wireless laser scanning, and it looks quite promising. So for comparison, I got roughly 90 FPS with the wired scanning, and here in the preview I'm already seeing 80 or 70 to 80 FPS. So it's, of course, it's above 60 FPS, so this is very good. And I guess this could even be just a limitation of my notebook. So here I'm like sit comfortably at 83 FPS, and my notebook is working quite hard to keep up. So I'm definitely hearing the fans ramp up in quite a fast fashion. But I would say the wireless scanning is very performant. Now let's also look at the wireless speed of the other scan modes. So this can be completed. And now let's have a look at the IR scanning. So let's select the VSCEL, and I will just have a quick check on the scan speed. So for comparison, wired, the IR mode can reaches 30 FPS. So let's have a look how fast it will be. Now let's enable the auto exposure. So like this. It almost does the removal again. Like this. Now I can start scanning. Yeah, and it also, I'm seeing like 25 to 27 FPS. So this is quite good. So what could be a bit of a problem, I'm currently also like live streaming the video feed of my my camera to my tablet for so I can see what I am recording. But yeah, this is quite good. All right, now let's save this and I will process the initial scans I did and show you the results. Now let's have a look at the processing results. So let's start up with the laser scanning. So this looks quite good. And as I aforementioned, maybe the exposure was a bit high, but especially here in the eye sockets, it captured all the way back, and even here in the nostrils, and of course the spacing between the teeth. Then let's go over to the full field. So this one has a bit less detail than the laser mode. So as I mentioned, laser mode is for myself, it's basically the way to go for smaller parts. And then if I had very large parts, I use the IR mode. But it also captured quite deep into like the eye cavities. Then we have the IR mode, and as I mentioned, I actually processed the mesh or the segmented scan because it was simply quicker. And as you can see, like in the IR mode, you have like the least detail of all the scan modes. So the details are a bit missing, like the space between teeth, but it has like a way bigger scanning area. So this is the reason there are other scan modes. And the last one was the hybrid. So here the hybrid one, and I would say this is as described, good mid-range between the auto or the full field IR mode and the VSCEL IR mode. And as you can see, you have more detail. And it still managed to scan all the way into the eye socket. So I guess this is due to the reason that the camera distance is quite near. So for the depth cameras, and the closer the cameras are, the better the deep hole scanning performance will be. So this is quite nice to see. And with this, I round up my first initial impression, unboxing, testing video. There will be, of course, like more proper testing coming, and also scans of my default or reference geometries, so you can get a bit of a better impression how it is positioned at the market. But from my current first impression, I'm very impressed. And especially the wireless scanning worked very good. And I hope this will also be the case for the smartphone-based scanning. And then I will also share, of course, my solution to a smartphone holder for the scanner. So have a good day, and be back with new videos coming.